Hi everyone, so here's my final solution. I don't mind admitting to you that things went a little wrong down here and I thought I was in another Knight's Tour nightmare, but it was because I went away from my original idea of going for the big numbers first. I filled in that 20, then I did the 5 and I thought, yeah, everything's going in a nice long thing, and I got into a bit of that instead of putting that 18 in early. So it did work, and there it is. Right, so it's circle theorems, which we did not all that long ago in class, and you guys did really well out on the whole, I reckon. So at the top here, I have put all the questions because we did all the Maths Genius stuff in class. So I've gone to Corbett Maths for these. It's a big file, so if you've printed it all off already, then, sorry if that's used a lot of paper, but we'll just be looking at these questions in class. If you have printed it all off, please do use those other questions as practice. If you've got a bit more time today, or maybe just give it a week or two and in a few weeks have a go at those other questions. I've also uploaded the solutions, so if you do want to have a go at those other questions, you can find them. Although anytime it says give reasons in this, quite a lot of the time he's just showing his working in his solutions, and really he should be talking about the theorems or whatever rules of angles that you're using as well. But for quite a lot of them it's just about finding the size of the angle, and if it only says find the size of the angle, you only need to do that. This is a 1 mark question, 1 mark for the right thing. Pause the video, give it a go. Now, a triangle in a semicircle has got a right angle at the edge, so that means that will be 90 degrees. You've got 180 degrees in a triangle, so if you take 90 away, that's 90 left. So if I do 90 take 29, that gives me 61 degrees. Here's part B. Once again, pause the video, give it a go. So we want to know the angle ACB, which is up here at the circumference, and the rule is the angle subtended at the center is double the angle subtended at the edge. So 112 divided by 2 is 56 degrees. On to question 2. The sentences at the top, sometimes they're worth paying attention to, but I would, when you're looking at circle theorems, just have a look and you know what you're looking at. That helps to keep things a bit simpler. Pause the video, give it a go. So this is what's called a cyclic quadrilateral, which just means a four-sided shape where all the apexes or corners of the shape hit the circumference. And that means that the opposite angles are going to add up to 180. So ABC, that's the second one, will be 180 take 95, which is 85 degrees. So that's part B. And this one here is going to be 180 take 62 degrees. Well, take 60 would be 120, so that would be 2 less than 120, 118. On to question 6, so once again, pause it, give it a go. Right, include your method this time. So what I could say is that angle there, because these are subtended in the same arc, those two are the same. So I could say PQS equals 57 degrees equal with PRS as subtended in the same arc. And you could say segment, so arc or segment will do there, whichever one you remember, because the arc is talking about the line I just drew. The segment is talking about, if I put a straight line across from P to S, it's talking about that part of the circle, if I was to colour all of that in. Right, so now that we've got that, to find y, I've just got a triangle here. So angles in a triangle sum to 180 degrees is fine for our reasons there. Then 78 and 57 makes 135, so that must be 45 degrees to make up to 180. On to question 7. Diagram showing the points. It's a kite. That's the most important thing. It's a kite and it's a cyclic quadrilateral. There we go. What's nice about a kite is this is exactly the same as that. It's just the mirror image, isn't it? So I know that this is 65 degrees. Now this is said work out the value, so we don't need to give our reasons, but we do show our working. Now I've got a triangle there, and this is a diameter. It says EG is a diameter going through the center there, so that must be 90 degrees. 90 plus 60 is 155. Take that away from 180 because the angles in a triangle sum to 180, and that's going to give me 25 degrees. Now always be very careful. It's a lot of times people will do everything right and then write 35 because you think it's 30 from 50 to 180 and then think 5 different. So do take your time on those. Pause it and have a crack at number 11. So we want the size of POR. So always a good idea just to sketch that in first of all. That gives me X there, but if I put that line in there as well, those are both radiuses. I've got another kite, and I've got a kite with two 90-degree angles there and there. The other thing is that this will have bisected this angle, so I can say that that is 22 degrees. Now I can say 90 and 22 make 112, and then we've got angles in a triangle again. So 180 take 112 will be 68 degrees. Strictly speaking, I don't need to put this degree symbol because it's there, but I just don't like that little one. It's so mouldy and tiny. Questione number 12. Pause the video, give it a go, folks. And it's good practice to say what the theorem is each time as you do it. But I'm just going to verbalise it. I'm not going to write it down myself. But it might be a good idea for you too. Right, so it's a tangent to the circle. And this looks like alternate segment theorem. I will write that down just because it's the... And very often, if this comes up, they want you to say what it's called as well, because that's the only way you can really get the mark on that one for saying why. And what it means is this angle here, remember this is the one about the windsurfer. You imagine the windsurfer upside down, it's the alternate segment. So I've got this segment here and then it sort of alternates round. So that will be 63 degrees, and you get the similar relationship from that one to this one. So that will be 61 degrees. Now, I haven't even thought about which one they want yet. Oh, they've said they want ABC. So ABC must be 61 degrees. On to 13 then. Have a look at this. Take your time. Just work out any angles that you can. If you can't see where to go on to get CAD, which is this one here. Pause it, give it a go. Right, now whenever you've got a centre and you've got lines from the centre, from the circumference to the centre, they are going to be the same length, and that gives us isosceles triangles. So if that's 42 degrees, base angles of an isosceles triangle are the same. So that will be 42 degrees because of base angles of an isosceles triangle. Only one mark, so we don't need to give the reason. Find the size of angle ACB. So we've got this one here being 42. So ACB, let's call that Y. And again, we've now got another triangle in a semicircle, haven't we? So, and you can use that as a reason for that being 90 degrees. So we've got 90 and 24 add to make 114 degrees. 180 take 114 is 66 degrees for angle ACB, and the last one is angle BCD. So I'm not going to go down there again, I'm just going to write down BCD up here so I remember. Sometimes it can be written like that. So BCD is this angle here, so it's going to be the 66 degrees that was Y plus whatever we have here. So if I call this bit here W, this bit here will also be W. And I noticed, now you may have found this another way, there's not hundreds but quite a lot of ways of working this out. This is another triangle in a semicircle, so 42 plus W must add up to the right angle of 90 degrees. Take 42 away from 90 and you get 48 degrees. So BCD equals 48. No, it doesn't, does it? BCW is that OCD is obsessive compulsion disorder is 48 degrees. We've got to add that to the Y, haven't we? What was the Y again? That was the 66 degrees, wasn't it? Yep, so 48 plus 66 is going to give us 100 plus 14 is 114 degrees. Right, got to crack on now. So question 16, pause it and give it a go. And hopefully you've got something like this. I began with alternate segment theorem to get that one there being 42 degrees. And then I said angles in a triangle sum to 180 degrees and added them up. You do need to put both those reasons down if that's the way you went. You might have done angles on a straight line to get that one there being 83 and then alternate segment theorem, but you would have needed it one time. On to question 17. Pause it, give it a go. Right, so what I would do here is I would say I know that that is 90 and that is 90. They haven't asked us to give us our reasons, but that's because a tangent joins a radius at 90 at right angles. Then you've got 360 degrees in a four-sided shape in a quadrilateral. 360, take the 180 of that one and that one gives 180 degrees for those. 4x plus x means 5x equals 180 degrees. Divide by 5 and you get 36. Here they go wanting reasons again, so pause the video and give it a go. So we want to know AOC, so that is our end goal. But let's work out a few other things first, because that seems a bit tricky straight away. Now that's a tangent and this is a radius, so I know that that is 90 degrees. Therefore I can work this one out here as being 90 plus 29 is 119. Oh, and I should give reasons, so I'll write that down. And 119, so 180 take 119. It's then a valid reason to say angles in a triangle sum to 180 degrees. And that means it'll be 61 degrees. Now, what else have we got? We've got a kite here, haven't we? So this must also be 61 degrees. And then I've got angles on a straight line. Sum to 180 degrees, and we could write that these two triangles are identical. What's the word for identical? and identical shapes where it doesn't matter, you've got to flip it over, all the sides and all the angles are the same, are called congruent. So we can say that. And then we've got angles in a straight line sum to that. So 180 take 122 is going to be 58 degrees. Carrying on, and if you know which two angles you're going for, then but actually they've told you, haven't they? A and B are singled in there as what they want to find out. So pause the video and work out any angles you can and see where you get to. Right, now this is not going through the center, so we can't say anything about that, but we can use, the first thing I see is windsurfer, below the sail, top corner there, they alternate segment theorem, that must be 35 degrees. Now if that's, we have got a cyclic quadrilateral here, so I know that this angle here and this angle here add to 180. I also know that these two here and this angle add to 180 because of angles in a triangle. So 180 take 80 plus 35, 115, so take 115, that's 65 degrees. And therefore A must be 135 because they add up to make 180. And then if I know that, I know that these ones here all add up to 180 altogether. And also, what else do we know? I must admit I'm a little bit stuck. Let's have another look at what's there. Oh, PQ is parallel to SR. I haven't thought about parallels yet. Oh yes, there they are. They've been indicated as parallel. And parallel lines, when you've got a line crossing it, that is alternate to that. And alternate angles are equal. So that must be 35 degrees. So this is 35 plus 80 we've already done as being 115, so these two must add up to 180, and so this this whole bit here must be 65, so B equals 65 take 35, which is 30 degrees, which leaves us about a minute to have a go at proving this. So pause the video, give it a go, and I'm going to go super quick. This is an isosceles triangle, so you can say AOB is an isosceles triangle. Then we can say that that angle there is a right angle for that reason there. Sorry about the noise. So this bit here, if I call that y, I can say y is going to be 90 take 2x. This here will also be y. So if I call this bit over here w, I can say that w equals 180 degrees take 90 take 2x plus 90 take 2x, because those two need to be added together. So that means I am going to be taking 180, but when you take a negative you add, so adding 2x and adding 2x there, they cancel out, and we can say that w is equal to 4x. And that's that. Okay, I hope you all have a wonderful half term, and we'll see you, or you'll see me afterwards, and hopefully I will see you all in the classroom as soon as possible, whenever that may be. Goodbye everyone.